This week, Lab TV travels to an Air Force research lab in Dayton, Ohio, where engineers are designing some very tiny aircraft.
We are in a program called micro air vehicles. Traditionally, the role of the Air Force has been very large aircraft. So you can imagine an F-16 or an F-22. It's very large. Lately, things have been getting a lot smaller because you want to go sometimes to places that you can't get in with an F-16.
The program is still in its early stages, but the Air Force has some big plans for these little planes, also called MAVs.
A micro air vehicle might sit inside a building. It might sit outside of a building and sit and watch a doorway as people come in and come out. And the nice thing about it, because it's so small, it's going to be harder to see the micro air vehicle. The idea is that it can sit there and nobody will notice it, and we can just gather intelligence.
These little MAVs will look and fly like small birds, or maybe insects. So the engineers are working with biologists to study some of nature's most talented flyers, including the hummingbird.
The hummingbird is an amazing little creature. It's smaller than this, and it can fly up to, say, a flower right here, and it can feed from the flower just like this. It can hover. If we could only do those same things that a hummingbird does, if we could travel a long distance, have that kind of endurance that a hummingbird has, and then suddenly stop and hover. And maybe if I had a camera on here, I could stop and hover and take a look at what's around me.
And they need to be able to navigate through a city, the way birds and insects can fly through trees.
We can learn lessons from the way that nature does things. Now, keep in mind that we can't just blindly try to build a bug or a hummingbird. We can't do that because nature has some tools that we don't have. So what we do is we take the technology that we do have and we try to design something that does the same thing as a hummingbird or a dragonfly does, but with our own tools.
They're testing a variety of hobby store aircraft to develop the tools they need so they can study things like aerodynamics, structures, and propulsion.
You have to understand the aerodynamics, the air as it flows over the wing. You have to understand the structure as it bends and as it deforms. You have to understand the controls, the electronics that are on board. You have to understand all of that.
Designing an MAV is not like shrinking down a big plane. When an aircraft is only 6 inches long, the whole science of flight changes.
With a large aircraft, the air, when it's traveling, the air will be flowing over the aircraft very quickly. Well, these ones, it's flowing over very slowly. In fact, kind of the way we talk about it sometimes is that the air is something more like molasses as it goes over. Viscosity has a chance to really grab hold of that aircraft. There's also the structural aspects. If you notice, when I fly with this little guy, he'll flap up and down, and this wing will actually deform quite a bit. Those deformations, that's not what you normally want. But these little airplanes, they are meant to do that. In fact, when we flap like this, the fact that it's deforming so much helps us get better efficiency in flight. It gets better lift.
An MAV will have to carry sensors, receivers, and a power supply, and still be light enough for stable, controlled flight. The team has to pack a lot of stuff into a very small package. Right now, they're doing a lot of testing and then analyzing the results on computers. But soon, they will be designing and building their first micro air vehicles.
I love science, I love technology, and I love playing with these toys, and I always have. So I just got lucky and found the right job that allowed me to come in and help the Air Force out by understanding these things. I try to come in early every day and I leave late every day because I play with toys all day.
To find out more about micro air vehicles and the science of flight, check out labtvonline.org.